I will use this example to demonstrate law of total probability. Let's read the text. Law of total probability. Suppose that the sample space S is partitioned into multiple sets B1, B2 up to Bk. So this notation, this one, so just means so the sample space S consists of B1, B2 up to Bk. So this notation so just means for any pair of B, so they are disjoint. Okay. So this formula so just tells us so if we want to calculate a probability of a set A, how to do. So what does it mean? So this means, see, suppose let's draw a picture. So suppose this is the sample space, okay, right? And suppose we want to calculate the probability of event A. Sometimes it may be difficult to calculate the probability of event A directly. So, but we can do in this way. Suppose S can be partitioned. See, like, okay, yeah. So suppose S can be partitioned into those so many pieces, right? So each piece is, so this is B1, B2, B3, B4, B5, B6, B7, and B8, right? So S is partitioned into different slices. So in this case, if we want to calculate the probability of event A, you can see, so A is also sliced into different parts, like this part, this is one, this is another one, this is another one, this is another one, another one, another one, another one, right? See, in order to calculate the probability of A, so it is enough to calculate the probability of each small slice and add them together. And for each small slice, for example, like this one, see, this slice belongs to A and also belongs to B, right? So this is essentially A intersect B2, right? So similarly, so like for this one, it belongs to A and also belongs to B3, right? So this is A intersect B3, right? Yeah, so basically, so this tells us if we want to calculate probability of event A, so we can calculate the probability of A intersect A1, not A1, intersect B1, and the probability A intersect B2, and we add them together, add up to a probability of A intersect B8, right? Yeah, so this just means, so basically the law of probability, so just means a law of total probability. So just means if we want to calculate the probability of one event, yeah, so if this event can be partitioned into several small slices, yeah, so we can just calculate the probability for each slice and then add them together. And so if we work one step further, because we have this formula, probability of A intersect B is equal to probability of B times probability of A given B. Yeah, so this is conditional probability. So basically, we just apply this formula to each item in here. So we will know probability of A equal to the probability of B1 times probability of A given B1 plus up to probability B8 times probability A given B8. Okay, yeah, so this just explains, so basically the formula we listed here. So let's look at this example. Let me erase everything first. Okay. Suppose a class contains a freshman, sophomore, junior, and seniors. Usually, so for this type of problem, it is convenient if we can draw a diagram. Okay, so let's see. Let's try to draw a diagram for a student. So, for a student, okay, so it can be a freshman, can be sophomore, can be junior, can be senior. Okay, yeah, so the proportion of freshmen, sophomore, and junior will be 1 over 8, 2 over 8, 4 over 8. And then it is known that, so basically half of freshmen, 3/4 of sophomore, 3/3 of juniors, 3/5 of seniors are female, right? Yeah, so basically for each of the people, I mean, freshmen, so can be female, can be male. And according to the problem, half of them will be female. Sophomore can be female, can be male. We know 3/4 are females. So junior, so can be female, can be male, right? And so not three, yeah, so 2 over 3. Okay, so this is female. And so for senior, okay, so can be female, can be male. Okay, so 3/5 are females. So it asks the probability of male. So if we compare with the previous, I mean, with our formula, right? So we will say A, yeah, so it's just the event of male, right? And so we have B1, B2, B3, and B4. And so basically, so they just corresponds to freshman, sophomore, junior, and senior, right? So then we can apply that formula. So first, yeah, so problem, I mean, the problem tells us some probability here, but some of the probability are missing. Yeah, so first we need to fill them, Yeah, so basically we just use the property that the sum of probability equal to 1. Yeah, because, for example, for the first level, so basically it can be a freshman, sophomore, junior, senior, right? And the sum of the probability will be 1. Yeah, so this has to be 1 over 8. Okay, and see if we look at here, female or male, and so of course the sum will be 1. So this has to be half. So this will be 1 over 4, 1 over 3, and 2 over 5. Okay, yeah, so if we apply so basically for each of the value, so in this level, right, so this just like the probability of pk in the formula. And so those probability in this level, it is just like the probability of A given bk, right? And so now we want to know the probability of male. We want to know the probability of male, or maybe the probability of A. Yeah, so we just need to calculate the probability, like, see, basically along the path. You can see for male, so it may go along this path to be a male, right? Or along this path to be a male, along this path to be a male, along this path to be a male. So basically we just multiply the number along the path. Yeah, so for the first path, see, 1 over 8 times 1 over 2, right? So then plus along the second path, So 2 over 8 times 1 over 4 plus for junior, so we have 4 over 8 times 1 over 3 plus, and for senior 1 over 8 plus 2 over 5, right? Yeah. So then if we do the math, and we will get 41 over 120. Okay. Yeah, so basically, so this example so just demonstrate how to apply the law of total probability to calculate a probability.